projects. In this video, I will be explaining about optimization of the hybrid movie recommendation system based on weighted classification and user collaborative filtering algorithm. Introduction. The project presents a high-level overview of the issues faced by growing accumulation of big data in context of online information technology. The project examines two traditional techniques to movie recommendation systems, which are content-based recommendation and collaborative filtering. It does, however, point out of the existing recommendation algorithms can produce high-dimensional arrays from massive datasets, which takes longer and may result in erroneous recommendations. Objective. The project goal is to improve movie recommendation systems in the context of big data by developing a hybrid movie recommendation system based on weighted classification and user collaborative filtering techniques. The primary purpose is to overcome the difficulties presented by high dimensional arrays from huge datasets, which might result in time-consuming and erroneous recommendations. The system seeks to extract critical information and organize similar behavior users into clusters by using a sparse linear model and K-means clustering. The addition of a weighted classification approach improves tailored suggestions even more, resulting in a more efficient and accurate movie recommendation system with lower computational complexity and higher customer satisfaction. These are the requirements for execution. In hardware requirements, operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above are required. In software requirements, Python IDEL of 3.7 version is required. These are the algorithms used in the project. First one is sparse linear model. It is a feature extraction and building the basic recommendation model. The sparse linear model is used to extract required features such as user ID, movie ID, and ratings from the dataset to build a classic recommendation model. This module is responsible for processing the dataset and creating the feature matrix that will be used for the further computations. Next one is local recommendation model training. It's a clustering user based on behavior and calculating local hit rate and average hit rate. Here, the extracted sparse features are used to train clustering algorithm called K-means. K-means groups users with the similar behavior into the same cluster. The similarity between user is calculated using the Pearson correlation coefficient or Spearman function. The trained K-means model is applied on the test data to predict the local hit rate and the average hit rate. Next one is top N personalized recommendation using weighted classification. Using clustering and similarity scores to provide personalized movie recommendations for users, it takes the user ID and movie ID as input and extracts cluster centers from K-means model. It then calculates the nearest neighbors between the input user and the cluster centers using Pearson formula. Based on calculated similarity scores, it returns the top N recommended movies for a given user. The weighted classification approach allows the system to provide more accurate personalized recommendations. Coming to the methodology, these are the design models for execution. First one is upload movie lens dataset. Using this module, we will upload dataset to application. Next one is calculate sparse linear model. Using this module, we will read dataset and then build sparse linear feature model. Next one is run local clustering algorithm. Sparse features will be put to K-means to group similar user into same cluster by using Pearson function. Next one is comparison graph. In this module, we will be plotting local and global HR and AR HR graph. Next one is run weighted classification. In this module, we will accept user and movie ID and then using weighted classification, we will predict movie recommendation. For execution, first open the code folder. This is the code folder and this is the dataset folder in that, and this is the movie dataset. Here we have movie ID, title and genre as parameter. This is the rating data. Here we have user ID, movie ID, rating, timestamp, user EMB ID and movie EMB ID. And this is user data. In this we have user ID, gender, age, occupation, zip code, age DSC and occupation description. Close this. and this is the main code file, and this is the run.bat file. Instead of executing project in command line interface, we have created Windows batch file for execution. So double click on it for execution. This is the graphical user interface of the project. With this, we can interact with the program, and this is created by using Tkinter library in the Python. First, click on the button Upload Movie Lens Dataset. Select the dataset and click on Open. Here, dataset is uploaded. We can see user details, movie details, and rating details. Now click on Calculate Sparse Linear Model button to extract sparse features. Here, we can see sparse matrix in the square brackets, and here we can see total records, which are 10,000, and total features found in dataset are 2, and then dataset is split into train and test. Here is the train length and here is the test length. Now click on the button Run Local Clustering Algorithm to build clusters. Here, clustering task is completed. We can see global hit rate and local hit rate. Now click on the button Comparison Graph. Here on x-axis it contains local hit rate and global hit rate, and on y-axis we have the count of that particular hit rates. Close this graph, and here we have to type user ID and movie ID to get the movie recommendations. So here I will be typing 2 and here 11 as movie ID, and click on Run Weighted Classification to suggest the recommendations. So for this particular user ID and movie ID, we have a predicted rating score as 5, and these are the top 10 movie recommendation list. Similarly, we can predict for other user ID and also movie ID. So here I will be writing 9, and here I will be selecting 33 and Run Weighted Classification. So for this particular user ID and movie ID also, we have rating score as 5, and these are the top 10 movie recommendations. Similarly, we can predict for other user IDs and movies IDs. Close this graph. Conclusion. The project introduced a optimized hybrid movie recommendation system for movie suggestions that efficiently manages big data and high dimensional arrays. The system produces accurate and tailored movie choices by using the sparse linear model, K-means clustering, and weighted classification. Clustering assists people with similar activity to be grouped together, whereas the Pearson method provides similarity scores for customized recommendations. The weighted categorization improves prediction accuracy by taking into account similar user behavior. The system performance illustrates its capacity to handle massive datasets and generate relevant and personalized movie recommendations, resulting in a more enjoyable and efficient movie selection experience.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.